co-founding xAI. What was it like working with Elon Musk?
He is the actual real founder. We agreed that we can call ourselves co-founder. We had a meeting with Elon, and that meeting sometimes ran extremely long. He might even run until like 2 a.m. He is like very technical, and he didn't make any decision until he absolutely understood things.
What are some key lessons that you took away from experiencing working so closely with Elon Musk?
His urgency. He treats time extremely, like values time very large. Every day, every hour, every minute counts for him. He is like basically speed is everything. Not being afraid of challenging.
Elon Musk say that his goal is to create the most truth-seeking AI.
There could be certain specifications of it that I could come up with, but I don't think they would align with Elon's intention completely. The Pope has tweeted something about AI. People analyzed that tweet and it turned out that it was AI generated.
What is a chip? I didn't know that you have to verify chips.
Chip verification is kind of like working on terabytes of data. Verification actually is more costly than designing the chips.
When we move to a future where everyone just cognitively would offload their things to AI, what do you think would happen to like humans?
Actually, I think the opposite of that question is even more interesting of how people get so intelligent at all. So I think we will have like superhuman mathematician AIs next year or two.
Awesome, Chris. Yeah, thank you so much for taking the time to do this. How I first came about you, Chris, was I found you through xAI. Well, when that launched, you were one of the co-founders, so that's how you first came into my knowledge. And I guess ever since then, I've wanted to chat with you. I've listened to some interviews. I've gotten a bit of a background on your history in sort of the AI space, but that's a bit of context on how I found out about you.
Yes.
Yeah, I guess, Chris, I know you have now moved on to a new company. You're no longer with xAI. I guess tell me and the audience a bit about what you've been focusing on over the last 6 months.
Yes, so originally I joined Morph Labs, which is a company, it's a cloud infrastructure company that helps to run AI agents, both for deployment and also in terms of like search algorithms. And so my main motivation was to use it for program synthesis and verification, so mathematical statement verification. So the reason I left xAI because I was more interested in terms of what I call verified superintelligence, which focuses on not just producing the output, but also guarantees that the output is correct. And also a validation that the problem we are solving is actually a problem that the human wants the AI to solve. So these are the main aspects of verified superintelligence. And so I joined Morph, where we started to work on an agent that can transcribe mathematical statements or like proofs into a programming language that's called Lean. And that's the property of that language is that it can be formally verified. So meaning you just run a verifier and then it tells whether the statement is correct or the proof is correct. So checks the correctness of both the statement and its proof. And so that is very much of interest for mathematicians. So it's a long-standing dream in mathematics to create a completely formal machine verifiable version of mathematics. And it's very tough because it's just a lot of busy work. So humans are not very good at it. And we were working on this agent that helps to automatize that progress and or that transcription. And also in the meantime, it learns to improve itself. So the idea is that we try it on formalization efforts where humans had a hard time formalizing. So we started with some simpler statements. That is a number theory statement, which is called the ABC conjecture. And we prove some very simple version of that ABC conjecture. That's a classical result. And we transform that classical proof, which is from the 60s, into a machine verifiable form. So the reason for ABC conjecture is being a target is that it has a controversial proof attempt that is many believe it's incorrect. So basically the idea is that we are transcribing mathematics into this formalized form, and First, we started with a simpler statement that was still very much of interest for number theorists. And then we moved on to a very classical result that's a harder statement is a so-called prime number theorem that describes the distribution of the prime numbers. And that was an effort that was attempted by Terry Tao and other mathematicians, Alex Kontorovich, and using the work of many students to formalize this statement. And they spent more than a year on getting about halfway through the proof, the formalization of the proof, and our agent managed to do it in a few weeks. So that was a promising result. And then at that time, we decided that our efforts were a bit misplaced in Morph. So Morph is a cloud infrastructure company and not really an AI company. And then we had like two choices. Either we continued in Morph, but then we had to explain investors and also new hires that why we are doing it inside Morph, or we just start anew and spin out the whole effort into a new company. And we picked the latter option. And this company is now called this Math Incorporated. So we want to target mathematics as our first goal, and then leverage mathematics to solve all the hard problems like program synthesis, engineering sciences, etc., by using guaranteed correct AI outputs. So basically, the AI should always produce proofs of correctness for every output it produces.
Got it. And is this new company called Math Incorporated?
Yeah.
Oh, okay. And how old is it now, Chris?
It's yeah, we started it early September.
Okay, so it's been nearly a month and a half.
Yes.
What's that process been like, Chris? Are you just looking for investors? Are you looking for customers? What's that journey been like over the last um, 30 to 40 days?
Yeah, so we are in. Yeah, so we already started looking for investors, but it was a bit hard to do it for Morph, and then we decided to go with the Mathing, and it's we also retained our. I mean, we don't really have customers in the sense that like it's not a paying product, but we have several users of our product, so it's a bit expensive to use. So we need a lot of compute to run the product, but I mean currently we are giving it out for very very high profile mathematicians that work with us, and that's they help us to improve our product and help us to create the AI that we would like to see in the future.
Got it, Chris. And in the new future with your company and what you're working to solve, how does it integrate to everyday people, day to days, when they use AI? Yeah.
I mean, most people it might not help much, but it's more so for example, if people program, then that could be a huge change. So right now the usefulness of AI is very much limited in the human effort that needs to verify the output's correctness. So often the AI produces almost correct answers, but it has like subtle bugs everywhere. And it's more work to fix them than actually write the whole thing from scratch. So therefore, I mean, AI has been like, so several companies now say, okay, don't even use AI for coding because it's just too much work to maintain that code. So if we could have this kind of workflow where first we are creating a specification that is human checked, that the specification is correct, and then we create the program, then using that workflow, the correctness of the output could be guaranteed and could be relied upon. So that would be one particular case. So programming is definitely a target. Another target is more like scientific work where you just want to check the correctness of a paper, or at least all the mathematical content in that paper. The third application is kind of engineering principles that like you want to design various objects and you want to make like thorough analysis that they are don't
do any harm, or they are correct. So for example, if the building doesn't collapse, or uh, whatever you create, it actually does what it's supposed to do.
Interesting. I don't have a technical background, but I remember I was coding something, whether it was like a script to change the create date for a bunch of files, or maybe it was just to install software. And I remember asking ChatGPT to give me a prompt for that for my terminal on my Mac, and it didn't work. So I copied the whole terminal history, put on ChatGPT, gave me a new thing, still didn't work, and I kept looping it. And after like maybe 10 attempts, then it finally got something to work. Is that me manually doing what you will build eventually will do automatically, or is that the same or different?
I mean, this is one component, so that the component we call search. So our system has multiple components. Search is just one of them. So the first component is formally describing what the user wants. And then the second component is to validate that it actually correctly transcribe the user's intent into formal language. And then the third thing is where you are trying to argue about the correctness. So you create, the third step is actually creating an output like a program. And then the fourth step is trying to prove that the program actually works, that it does the right thing. And then you can start iterating on it, as you mentioned, and then you are searching for the right program. But the good thing is that since verification is built in, the system knows when to stop. So if you wouldn't have a clear verification step, then there wouldn't be any clear criterion of saying, okay, now you are done.
Yeah, I've been using ChatGPT a lot, and I'm wondering, like, sometimes I would have an email chain. I'll download the email, I'll upload it to it, and I'll be like, hey, give me a good reply. Good is such a broad term, but it somehow gives a response that seems to be pretty sufficient for what I need. Is it gone through all my previous search queries and it knows me because I use it every day, or is it generalizing what good means?
Mhm. Yeah, I mean, I'm not completely privy to how ChatGPT works internally in terms of knowing the user. So probably it has a history of the user's previous conversations. So that's what most cutting edge models do.
Got it. I guess, Chris, were you always born this technical and this math heavy? Is it something that you learned? Was it nature or nurture? Where do you think sort of all this came from?
I mean, okay, so I'm math heavy. So I studied mathematics, so I definitely nurture like a lot. But yeah, I mean, always liked to think when I was kid, but I was not particularly good at math in the school. I mean, I was like good in the class, but not like excellent. But I mean, elementary school mathematics is kind of like very different from what mathematicians do. So it's very hard to tell if a kid is actually mathematically interested or not. So yeah, I've grown up in a family with people who were much more gifted in mathematics from early age. So both of my brothers are very good mathematicians. So I'm kind of super mediocre or even less.
And I guess, given both of your brothers are that talented, what are they working on? Are they also in research? Yeah.
Yeah. So my younger brother is researcher in a Hungarian research institute, but he was professor in Toronto, which is one of the best universities in the world, but he decided to go back to Hungary. And my other brother is at Rutgers, and he does computer science, but very theoretical, mostly mathematics, and he won the Gödel Prize twice, so he's pretty well known in complexity theory. So yeah.
And Chris, do you have any children, and are they into math?
Yeah, my son is very good at math, yeah, and he likes it.
How old is he, and how did you have you been personally teaching him math?
Yeah.
Yeah.
So he's 15, and I mean, on and off, I'm teaching him math, but he also good at in school and almost in any other subjects, but math he's extremely good, yeah. And he's also into programming, and he always asks really good questions. So and always looked at math videos even when he was like 4, 5 years old. He was looking YouTube like videos about infinity and stuff. Yeah.
Wow. And is he self-taught? How do you teach him? Does he just follow the school curriculum? What's your advice on, especially with your knowledge and just seeing how smart these AI LLMs have? You can sort of like self-teach yourself anything. How has he been learning math and coding?
Yeah, he's much more conservative than I am because I mean it's like he's mostly learning from me and teachers in the school, and he's not really using any AI for this purpose or even at all. So I try to teach him like using AI for coding, but he's rather figures things out by himself than letting the AI do. He thinks it's kind of a cheating. He doesn't like to do that. He enjoys the process of discovering. I think it's probably at some point he will become more efficient by also like learning from AI, but now he is still like trying to do everything by himself, which I find it's a good quality.
When we move to a future where everyone just cognitively would offload their things to AI, like what do you think would happen to like humans as our brains? Because like when we stopped having to hunt for food, our body's just gotten very soft and fragile, and I guess we supplement it with these gyms. You would pay to go to a gym to move your body. What's going to happen in a future where people just cognitively offload everything?
Yeah, it's a very interesting question. So I thought a lot about that. So actually, I think the opposite of that question is even more interesting of how people get so intelligent at all. Because actually, for example, we look at the math that we are creating is completely way, way, way beyond what humans needed for survival, is intelligence. So why did it even evolve to this level? And so that's why I think that humans have an innate, at least some humans somehow have an innate need for thinking a lot and being like naturally very like thoughtful, and they figured out a lot of things that were not really necessary for survival even when nothing was around or people didn't even write. So if you look at like very old Go games, like the game of Go, and it's several thousand years old, and even the 2,000 years old games people were playing as well as today's professionals. So some humans have really a need to get really sophisticated in thinking, and it was not because they needed it. It was because they liked it. So that's why I think humans will always, there will be, I mean, a large section of people who don't like to think that much, or they just like hang out and do like easy things. But there's a few percentage of people who likes to do tough things, and they will be always around, and they will be always thinking about stuff, even if AI is much better than them.
Wow. Chris, do you think we'll move into a future where AI will just be so efficient and will be able to generate so much output and people wouldn't need to work anymore and would move to like a universal basic income? Is that where we're heading? And is that a good or bad future?
Yeah, I mean, I'm not to judge. So, I mean, I have no idea really. If we move to, I mean, universal basic income needs a world in which most almost all of the work is completely automatized, and I think that's several decades away. So I think we will have like superhuman mathematician AIs next year or two. We will have like AIs that can solve protein folding or design fusion reactors or whatever. But I mean, cleaning your kitchen is still something we need humans for, or a massage therapist, or a dance instructor, or whatever. So yeah, there are a lot of jobs that you don't, and yeah, I don't see that they are at the danger of being replaced by AI. Yeah, and it will take a while, even if we can. It doesn't mean that we will. So yeah, I think universal basic income can only become a possibility when we are automatizing to that extent that human labor is almost so completely replaceable, and we can basically generate almost everything that humans need. Because until then, we still need to motivate people to do some work that otherwise they wouldn't do. But I mean, it might be that we start creating a general income that's slowly rising, and when people like so get more and more freedom, and then there is a choice that okay, do we want to work or do we want to just have fun? And some people will choose to still be creative, create things, or help others. Some people will just hang out and enjoy life. Who knows? So, uh, but I think it's not realistic that we have UBI within the next decade or two. And it's mostly because AI will take slower to actually solve. Like the simplest looking tasks are the hardest to solve by AI.
Makes sense. If someone is sort of in their 30s and they're listening to this, Chris, and they're trying to see what the next 5 years looks like, and they want to see where they should, if they're starting a business, what they should do, because AI has automated advertising, email marketing, sales, e-commerce. Should they move back to traditional things such as cleaning business, dancing instructor? Like if someone's in their 30s and they're like, a lot of these things are being automated, like how do I make money now in this new world? What advice would you have for them, Chris?
Yeah, I mean, there are two kinds of people. So one kind, I think we have a lot to automate. So probably the most lucrative business is automating things using AI. Then you have to basically get into that business of doing that. And I think that there is still a long, long time that we will do that. Yeah, but I think a lot of people don't necessarily have the skills or the will to do that. And of course, there are a lot of creative works, and people just like to hang out with people, and they're happy to pay for certain, like, for example, even just getting advice from people or being taught by people. So you don't necessarily want to, even if in mathematics, it's a good thing to have an actual human teacher and have a human touch, even if that teacher uses like a lot of AI to teach the student. So yes, there are a lot of professions that are naturally like people just enjoy other people. I think the general tendency is that a lot of those user-facing things, like for example, YouTuber or like YouTube videos. People can get a lot of AI generated content that's getting pretty good, but still people start to become allergic to it, and including myself. So I don't really want to listen to the best AI generated video even. I'd rather listen to I'm really like crappy. I'd rather listen to a crappy human video that's authentic than a really nice polished AI generated video. So I think things will change because AI will be so super cheap and everywhere that people will consider it's kind of like plastic. And then if everything is plastic, then people start to value wood and metal and glass and all that stuff. So same with AI, so that you don't want everything to be plastic, basically.
Yeah, because I was just wondering, like, I've seen those AI videos, Sora too. It looks so realistic,
Yeah.
where it can create. If I asked it, hey, could you please create a Zoom call with me and Chris and make it look real and have a fish tank? It would make something similar. It would create the same grainy, blurry effect, and it will recreate the same imperfections.
Yeah, to some extent, yeah.
So like,
But it's still, even if you just know it's AI, then that's already enough to, even if you cannot distinguish, but just know it that it's AI, then already that's enough to disqualify it. So yeah, but I mean, it's surprising. But yeah, I mean, you still can tell. So I mean, of course, if a year ago you showed me a Sora video from today, I wouldn't have told. But now I can tell. So it's like I saw enough of it so that it's sometimes I enjoy it. There are funny Sora videos that I actually, but I mean, they're getting old very quickly. Then you actually start to learn those really small differences that make a Sora video kind of like artificial. And then if you recognize those, then you start to become allergic to those details. So that's at least me. And yeah, and then people start losing interest. So they want real human, not like computer generated humans.
yeah, because I was going to ask, I understand people becoming allergic to all the fake AI slop.
Yeah.
Is there a way to verify that, hey, this is a real conversation? Like I'm watching Chris speak to Andy. This is not is there any verifiability process that maybe can be done?
Yeah, it's surprisingly easy for AIs to tell whether something is AI. So that's so-called an adversarial process. So basically, you can train AIs to pinpoint other AI. So you train the AI to try to fool the checker and then back and forth, and that's adversarial generation. Actually, one of my early results in AI was this kind of adversarial examples that I discovered in 2011 or 12, something like that. One day of that you can change pictures of anything very, very slightly so that all the AIs get fooled by them. And it's still true to some extent that's basically so machine learning, so computer vision can be very sensitive to small details that humans don't perceive and vice versa. They put in like small details that humans don't perceive but other AIs can perceive. And it's relatively easy to verify. It was also a funny thing that just now the Pope has tweeted something about AI. And it was saying a warning that, yeah, AI is great, but you have to maintain like a AI that is like developed with high ethical standards or something like that. And then people analyzed that tweet and it turned out that it was AI generated. So the Pope used AI to generate a tweet warning people about AI.
How could they tell that a tweet was AI generated? I guess
Yeah,
there's
I mean, I'm
little.
not sure if it's really AI generated, but there are like small hints of like how it puts the commas and the dashes, and so all these things that AI can capture. And there are several tools on the internet that can tell AI generated from not, and all of them consistently said it's 100% sure that it's AI generated.
Wow, that's so ironic. Yeah. Wow. Chris, what makes you so passionate about, formal verification, AI? Why is that something you're currently really passionate about?
I'm not currently. I was like, yeah, I mean, that's my dream from, I think, like since high school, but back then there was no AI, but also thought about AI back then. And maybe because I have like these very clever mathematician brothers, and I thought, okay, I cannot beat them, but maybe with AI I can beat them. But AI will be more clever than them. I cannot be more clever, but AI can. So yeah, and then I started to work on it at Google since 2016, and since then I didn't stop.
So I guess, Chris, like, what is formal education in like a more simple term that someone like me can understand? So like when I say the sky is blue, then we need to define what blue means. Does it just keep going backwards? Is that what formal?
Yeah, so you cannot formally verify that the sky is blue because there is no formal definition of what does it mean the sky for Okay, so you can say that the wavelengths of this and that is between this and this range, and that's what we can call blue. And then you can actually boil it down to something mathematical, and often you can, even if it doesn't look like that. But real formal verification is much more about like following very mechanistic rules and being able to say that something is correct from extremely simple principles, we call them axioms, that everybody accepts because they are self-evident. Like, for example, saying that there is always a number that is one larger than a previous number. So for every number, there is a number larger just by one larger than that number. That's everybody say, yeah, sure, I can accept that. Or there is zero. Okay, yeah, let's have a zero. And zero is zero plus, and that number is that when I add it to any number, it's always the same. And that's another axiom. We can accept that. So these are very simple axioms. And then if you want to, at some point, you say, okay, now here is a statement, and then at that statement, we can prove from axioms, and that's the first statement where you actually use some process, so that requires a proof. Of course, you can assume everything as an axiom that is true, and then you have nothing to prove, but mathematicians try to find the minimum number of statements that actually spans so they don't want to use too many axioms. So the number of axioms should be as few as possible, and that's basically we have like axiom systems that are very small, like a dozen axioms or like 5 axioms even. Then you can derive like mechanistic rules, and those mechanistic rules is more like you can just really check with a very simple computer program that the next statement actually follows from those statements. So then the goal is kind of like similar to solving the Rubik's Cube, that you say, okay, here is a situation, that's the pattern on the cube, and then you have to find all these elementary operations that go back to the solved Rubik cube when every side is the same color. So it's basically that's also a kind of a proof that okay, I can. So it's a proof of a statement that some element is in a certain subgroup mathematically. That's how they call it. So basically, these mechanical checks can be checked by computer. So you don't need any human that decides what is a correct proof and not. So previously, before the 1900s, so even in the 1800s, like people were just thinking, okay, mathematics is something that you are just conversing with somebody until the other one is convinced. And in the early 1900s, it completely changed, and people said, "Yeah, we need something that just uses mechanistic rules, that doesn't even need a human to check whether something is correct." And Russell wrote this Principia Mathematica in the early 1900s, which was like took I think several hundred pages to prove that 1 + 1 = 2 from the simplest possible state. So very, very detailed steps. So, and that is formal verification. But the good thing about formal verification is that it's 100% certainty. So once you prove something formally, then there is no other discussion about it. And it's not really just like something mathematicians are interested. So formal verification is pretty much used in every computer chip that people use. So whenever people design a computer chip, they do a lot of like optimization on that chip, and then there were a floating point bug in the 90s when they didn't do formal verification yet, and then somehow the chips were broken. So it cost Intel several $100 million to replace all those chips. And then said, okay, now we have to verify. When we build a chip, we will prove 100% using these formal tools that mathematicians developed that the chip is actually working 100% correctly. And since there were no such logical mistakes ever in chips.
Wow. Is AI currently smart enough where you can give it 5-6 axioms and tell it, hey, based on these 5-6 axioms, formally prove this?
Yeah, I mean, that's what we are trying to do, essentially.
I see, because right now, like, if I talk to an LLM and I was like, hey, could you please create a script that is 50 words using year 3 language, add some controversy, include an enemy in the script that we want to debate, and I want it to be about making money online. So I could give it a bunch of these axioms and it would somehow give me a perfect script. So I'm quite surprised. Okay. Could it do the same thing?
Okay, I wouldn't call them axioms. I mean, you can think them as of axioms because, I mean, these are more like constraints or specification. So constraint is the properties that you want your artifact to satisfy. So artifact in this case is the produced text, right? And then you want certain conditions on that artifact. So in the first step, when we want to do formalization, we are creating a formal specification of what those constraints are that we want to satisfy. So for example, one constraint in this case, okay, it should be less than 50 words, and then the specification could be a program that counts the words, and then you say this program, the output of this program should be less or equal than 50. And that's an easy constraint to specify. But I mean, add a controversy to the text. I mean, that's a very hard constraint to specify. So it's not even verifying it is hard, it's specifying it is hard. So that's why formal verification is good for mathematical content, like this text is at most this many words, but it's really poor for like fuzzy constraints like this, because there is no formal proof that something contains a controversy. But there could be like stochastic statements of saying that the probability of the controversy in this text should be greater than 95%, and then you could use stochastic methods to actually argue about these fuzzy concepts.
Got it. So formal verification in mathematics, does it work? Have we solved it and the only problem is it takes a lot of time? Or we can't formally verify things actually yet?
No, I mean, we have formally verified a lot of things, and so the principle is there. I mean, the process by which formally, so basically the whole logic system and and how to describe formally something and how to prove something formally, that has been introduced in the early 1900s. So since then, and also Gödel and Turing, they worked a lot on elaborating on what is possible and what is not. And then people developed all these programs that can automatically verify proofs if they are in the right format. But writing those proofs in that right format is extremely complicated. So if for a human, it might take like 2 minutes to prove something that it's like it can tell it to me and I say, yeah, it sounds like right. And then it can take him like a week to write it in a way that the computer can check. And it can be like hundreds of small steps, like really, really meticulous small steps. And since the 80s, people have improved these formal verifiers a lot. So it might be now it's only 10 steps, but it's still like one line of a proof. And it still needs like 10 steps that are very hard for the human to come up with those steps because they are kind of like programming language steps. So it's like not really like human don't like those. So it's in some sense it's solved because we know that so how to do formal verification and formal specification and what is a proof. We know this theoretically, but nobody likes to do it because it's just too cumbersome. But sometimes if you have hundreds of $1,000,000 on the line, like in a chip design, you have one error in your chip and then you have to replace all the chips. Then you bite the bullet and say, okay, I formally verify.
Wow, so right now there isn't a automated software or AI that quickens the 10-step verification process, and that's what you're trying to solve and build.
I mean, yes, so it's like there are certain automations, but they used to be very weak, and with AI now it's much faster. So it's basically kind of like the similar thing as with programming. People developed a lot of new nice programming languages, and then so originally it was very slow to write program in assembler, and then people devised like Fortran and C, etc. But they were also not very convenient, and then we came up with Lisp and Python and JavaScript, and they are all a bit more convenient, but not much more convenient, right? It's still a lot of work to write something in JavaScript, even if it's much easier than writing it in assembler. And the same thing is with these formal theorem provers that, yeah, it's still much work. Then write a human proof might take like 2 lines, and then you have to write like several pages of computer code that is verifiable. So it's still not good. But with AI, what we are doing is that we can cut down that time like 100x and with our system, and that's what my company is doing. And we expect that to be cut down even by another 10x by next year and be completely autonomous. So basically the idea is that you just throw in a whole mathematics paper and then you just let it run overnight, and then in the morning you get a complete format check of your paper if it's correct. If not, then it would explain, okay, here is a problem with your paper. I couldn't formalize or I couldn't verify this. It might be a real bug. And so currently, people, when they verify mathematics paper, it might take years for like another extremely accomplished mathematician to go through that paper and then say at the very end, yeah, I really believe this paper is absolutely correct. So it's like people wait like a year or two for their papers to be reviewed. Now it could take minutes or days.
And Chris, to compress that time with your AI or your software, what's currently the bottleneck? Is the bottleneck the speed of the GPUs or CPUs or what the computers? Is it trying to figure out a more efficient process? Is it just needing more data? What's the bottleneck to get there right now?
Yeah, so our current models are still not as strong as being able to process everything. So it's like they might run for infinitely long and never come up with the proof, and even if it's obvious for a human. So, and one of the reasons is that, I mean, we need to train those models for this purpose. So if we would have put a similar level of effort into making these models really good at reasoning as we put in just general LLM training, then I think we would be already there. So we need better training methodologies and also algorithms that can find the relevant facts better. So that's called a retrieval problem of like saying, okay, I want to prove this and this, and which facts are most relevant for doing that. So that's kind of like a detective work that humans also have to do. Is like, okay, when you figure out what I have to use, then it becomes really easy. But you have to find the right facts and the right statements that you already have proven. So yeah, that's basically these are the big questions of how do you. And also the third thing is that if you introduce some new statements that you know they are true because you have proven them, then you want to use those new statements. How do you make the system utilize the newly created statements, so that you immediately use them when they are needed? So yeah, these are the main challenges there.
Who else is in the company, Chris? Is this basically what you do day to day and figuring out all those challenges? Is that what you spend most of your time doing?
Currently, not that much, but yeah, I mean, I'm involved a bit in it, but and I want to get involved more. But yeah, we were like, uh, so there are various aspects. So I was involved quite a bit in fundraising or hiring or making plan strategy. But yeah, I mean, I want to get back more to technical work. But currently, our company is in the infancy, and we need to find the right people to work with us and secure funding so that we can run our experiments and models and improve the product.
And Chris, what has been your approach to hiring and building a team and finding the right people?
Yeah, that's tricky. Yeah. I mean, I have worked with a lot of people over the years, so I can talk to them and they can suggest people or just like gossiping, and then you figure out somebody left somewhere and then we can jump on them. But yeah, discovering new talent is harder, but I like to work with young people. So I most of my best colleagues. So even Jesse, he was a student when we met, and I tried to hire him at Google because I found him very clever. And but he went to OpenAI instead. So yeah, I typically chat a lot with people, and I think it's like you very quickly say, okay, are at least your interest aligned. So that's the most important things. Is this kind of like the common like enthusiasm for the same things. And if that's given, then the question is still, are they really productive? And that takes a bit longer to tell. So, and in a small company, we cannot afford like hiring anybody who is not even slightly excellent. So we need to like be super diligent. So we have a process that we don't really interview people in a standard way. We give them some tasks to work on for a few days and then see how we work together and whether they can accomplish anything on them. And those are typically very hard tasks, like some tasks that we actually work on already. And then we see how they approach it and would we like to work with them. Yeah, so that's our goal. And sometimes you have like really like people you know over the years and they did a lot of good work, and then you say, okay, I mean, I just happy if he joins us, and then we just give an offer immediately. So that's that's possible too.
That's cool. Chris, what was it like co-founding xAI? Like, did it start with 0 people? Were you literally member number one? And like, how many
Yeah.
people did you hire? What was it like working with Elon Musk? Tell me about that story of
Yeah,
building that team.
in the first version of Rippling, where this is the system that maintained me, I was employee number one. But yeah, it was technical because I mean there were other guys who were starting to work earlier, but they couldn't officially join because of visa issues, and they're like, but yeah, there was a founding team, and we were talking to Elon quite a bit, and we had a lot of discussions, and yeah, I mean he is the actual real founder, but I mean we were more like members of the founding team, but we agreed that we can call ourselves co-founders. But yeah, it was quite. We had a lot of freedom in terms of in the first year at least that he was like more like allowing us to roam free and just like let him impress, but then he got much more hands-on like after the first year with when the Colossus started, and he decided, yeah, we need our own cluster and it should be big, and then he became very pushy and very like high expectations on everybody, which is good. Yeah, and yeah, he got like more like expectations on everybody and the whole team.
How many people were in the founding team when you first started? And just before you left, how many people did it grow to, or did it stay the same?
And yeah, I feel definitely not the same. I mean, the founding team was like 9 people, 8 or 9. I mean, maybe 12. I don't remember exactly, but yeah, it sounds like 10-ish. Yeah. And yeah, I mean, okay, so the question is how many people were at xAI officially? So we had a lot of tutors when I left. And those basically we never even met them typically too much. They are more like they were also employees, but not like technical stuff. On the technical stuff, it was still the team was much smaller than, let's say, OpenAI or other companies. We had like two-digit number of people when I left, like 50 or 60 of the technical people. So yeah, but the first year was very slow growth. So it was basically at the end of the first year, we had only less than 20 people, like 15 to 20. Yeah.
And when Elon was letting you guys run free, were all 10 of the founding members, like, who was leading it? Who was guiding the project for xAI? Who was the
I mean,
main?
we had every week we had a meeting with Elon, and that meeting sometimes ran extremely long. Like he doesn't stop until he is actually feels that he is finished with everything. So he might even run until like 2 a.m. if he thinks that he needs some. So it happens sometimes. So uh, but he doesn't want people to sit around if they don't feel it's productive. But I mean, people often like to just stay. So it's basically you say, okay, if somebody doesn't have to be here, they can leave. So that, but yeah, it was so he doesn't want to waste people's time. But yeah, it was so he was very much involved, and we had like a chat group that we chatted with him about various topics regarding the xAI. So yeah, and yeah, it was. There were a few people like Jimmy Ba and Igor who were very much in like deciding on the main steps. Yeah.
Were the meetings with Elon Musk really long because he was just trying to understand and learn what was happening, or was he trying to convince you guys what he wanted? Why did the meetings go long usually?
I mean, there were sometimes like technical decisions to be made, and he is like very technical, and he didn't make any decision until he absolutely understood things. So he is very good at this. So I mean, he's not a typical CEO. He's not like, okay, do whatever, you just have to work. He really goes deep into stuff and has opinion on about everything, and he wants to know a lot of details. And then he thinks about, okay, how can we improve things? What are the common assumptions that could be challenged? So yeah, he's a very very different kind of CEO than most. I mean, I think he's completely unique. Yeah.
Wow. And having worked with him and having the technical knowledge you have, how technical is Elon? Like, is he just surrounded by smart people, or is he really smart and knows what everyone knows?
Yeah, he's very smart, of course. So also but what it's more important than being smart is that he is very, I mean, very inquisitive. So he always challenges, even when other people would feel it. I mean, they would feel self-conscious and say, okay, I mean, everybody thinks this way, I cannot challenge this. He likes to challenge those things the most. And very often he is wrong, but he is not afraid of being wrong. So he says, yeah, why not do this way? Why not do that way? And then even if everything is refuted, then he comes back to it again and again, and then makes other people to refute him more and more. And then only if he's 100% convinced that there is no way that can be done, then he gives it up. Yeah, so he is very insistent so on understanding. So he takes impossibility not lightly.
Got it. I see. And I guess now that you've sort of gone off on your own, Christian, and you've worked at Morph and now you have Math Incorporated, what are some key lessons that you took away from experiencing working so closely with Elon Musk?
I mean, of course, the most trivial thing is his urgency. He treats time extremely, like values time very large. So he every day, every hour, every minute counts for him. And he is like basically speed is everything. So that's one thing. The other thing is that not being afraid of challenging everything, even if somebody is a much So somebody is an expert for 10, 20 years, you can still think, and you better ask questions, and sometimes it turns out that his knowledge is not relevant in certain circumstances, and it could be improved upon. So this kind of critical thinking. Often it turned out that he couldn't improve something, and he tried hard. But even if it happened like 1 out of 20 times that something got better, then that was basically it's a big win. So and that happened several times that he could shave off, let's say, 2 days of making the data center running because he challenged a lot of things, and then things could be done parallel that otherwise couldn't have. So yeah, he's very insistent of like not giving up improving things until he's absolutely certain. So that's a very good property quality. Yeah. And also, yeah, I mean, he's very efficient in terms of like trying to focus on to only the more salient things and ignoring all the less salient ones.
What was his goal or his current goal with xAI? I know you guys sort of had different goals. What was the one that he was focused on?
Yeah, I mean, I don't want to go too much in detail on that because I have my own theories, but I don't want to talk about them. So he had several goals, and I think he is relatively open about some of them. But I don't want to talk for him. Yeah, you can just read his tweets. And the ones that he's not talking about, I don't want to speculate publicly.
Awesome. Chris, as we're moving with like, should someone like me learn and invest time into learning how to code? Because like AI is getting so good where I could just tell it, hey, build me an app that keeps yelling at me until I fall asleep early. And it'll build that without needing any technical knowledge. What's your recommendation?
I mean, I doubt that actually. So you can do it, but it will be crap, but currently at least. So I still think that is a reason for learning to code, at least to be able to judge the system that the AI writes. But I mean, AI is still very early in terms of being able to produce a significant amount of coherent code. So that's what we are working on, but it's not easy. It's not given, even now. So it looks like if something is 98% correct, that's almost completely crap. You cannot, it works in certain circumstances, and then you want to change something and it breaks something else, and then you always have to go back. So AI is not good at yet. So it's surprisingly good uh, uh, for what people thought would be possible a few years ago, but it's still not very usable.
So at age 26, what would be your recommendation on how to, like, what's the best way to learn how to code? What language should I be learning? Where does someone start?
I mean, it depends on what you want to code. So if you want to code for the web, then it's probably JavaScript. If you want to do something like simple logic, then it's Python. So Python is very often a good choice. And then if you want to solve something super efficiently, then you need something like C++ or Rust. But I mean, these are hard to learn languages for a beginner. So Python is a relatively simple language, and that's what I typically use with my kids to teach them. I think coding is not a single task. It's kind of like saying, okay, how do I learn to write? I mean, it depends on what you want to write. If you want to write your shopping list, then that's a different story of writing a novel or writing a screenplay, or if you want to write a technical document, all these things, or just writing emails or text, they are all different writings, right? So there is no one single task of writing. And the programming is even more diverse.
Yeah. So I guess, let's say the goal would be, I just want to be able to have a bit more vision. Like right now I'm just blindly trusting AI, I'm blindly using technology, and I'm blind. So I'd like to at least have some vision and be, yeah, that's my goal, to not be blind.
Yeah. I mean, if you just want to understand what code means and how it works, I think Python is a good choice. And then I would learn on some. So I mean, I'm not sure actually. So it depends on. So I generally think that people are most motivated doing something that they actually want to do and they are interested in the outcome. So for example, if you want to write a game, then you can write it in Python. But if you want to write a web page that does certain logic, then you need like JavaScript. I still think it depends on your interest on what you want to. So you have to pick first a task to accomplish and then try to solve it. and then figure out, ask a language model for, what is the best language or tool or library to do that, and then learn those things. So the way I would like my son to use AI, and he doesn't like to, he rather uses search engine and doesn't want to write code. But what I think would be the most productive is to generate like simple pieces of code for certain purpose, and then still write the whole code by yourself, but use the AI to look up the right way of the right idioms to write the code.
That's a great suggestion. I'm definitely going to do that. Yeah, I think like one of the things I'd like to do is when I post clips of my podcast, I manually go to YouTube, X, Instagram, TikTok, and I post it one by one. And maybe I could ask ChatGPT, teach me how to build a app where I can post it once and it distributes on all those platforms, and teach me how to use the API hooks and how to put it all together. And in the process of building that out, I'll learn.
Yeah, that's a good task. It's challenging, but yeah, it's a good task. I mean, so it has a lot of components like authentication and sending the message and then checking that the message is there, etc. So yeah, it could be a very interesting programming task.
Okay, I love that. And Christian, how do you personally use AI in your day-to-day life?
Oh,
How do you
really?
use
Yeah.
AI?
What?
Do you personally use AI, and how do you use AI day to day in your personal life?
Yeah, I mean, I'm using it for more and more tasks. So I mean, I started to use it for coding mostly, and coding meaning like finding the right libraries and getting some small example codes and that I can use as a template to go from them. But now I'm using like very much, like I use Grok for thinking mode a lot. So fast Grok for fast thinking, and it's very good at, like, for example, even so all kinds of problems, like for example, like comparing different products for a purpose. So let's say I want to buy like a loudspeaker, what are the advantages, what are the best ones, or I want to do some house renovation, which companies do these kind of things locally, and they fight for me. Or so basically, a lot of things that previously took like a lot of web search and often I didn't end up with. Now it's so basically automating this uh, uh, research process for various services or comparing certain offers. Yeah, I use them a lot. So for example, like comparing credit cards, I do, or what needs a building permit. So if I want to build a sauna in my garden, do I need a permit or stuff like? And then it goes into which city is it, and then it goes to the right pages on the city, like the website, the local codes, and then finds out. It's amazingly good at these things already. So yeah, I mean, I can do a lot of things much faster than I could a year ago. Yeah.
When you ask Grok, find me a local sauna builder, is it scraping Google? Where's it getting that data?
Yeah, I don't know exactly. So I mean, it's browsing around and finds link, I guess. But I mean, I don't want to speculate. So I saw the very early versions of that product, but I think it evolved a lot. I thought that those versions that were like when I left it were like this thing was developed for 2 weeks or 3 weeks, and I work closely with that guy that was developing it, but. I mean, I think it's very different. So it's much better than it was back then. So I don't know exactly, but it was like following links a lot and doing certain searches, but also internet like lookups, etc. So yeah, it's I don't know the exact mechanism, but it does a lot of thinking and searching, yeah, and following links.
From listening to a previous podcast, and you were just sharing your work history, you seem to be always ahead, and you've always been doing things that not everyone else has been doing. I guess I know about your current project already, but I guess like, what are you currently predicting in the next 5 years? Like, what is a lot of researchers or people who are technical? Well, what are people not doing that you think will be the next thing?
Yeah, for example, what I'm doing, I'm trying to do the highest impact thing that I think is not done enough. And I think people have a hard time understanding still yet why it's important. So yeah, I think that this kind of like making AI actually useful is a very important thing, especially for technical domains like programming and sciences and engineering. So that's where most my interests are, and I think people try to do it, but I don't believe in their approaches completely. So I think when people just try to use AI completely like informally, meaning that everything is just natural language text, I don't think that's the right thing. Also, I think like the models should evolve because they are still very inefficient. So I think they could be much more efficient. So at least like 100,000x more efficient. And so that will change. I also think that we will see a much more AI integration into a real world. So like basically AI connected to cameras and listening to things and observing or even like doing some work like more integration into, let's say, like the small appliances that like vacuum cleaners and others, but even like so that this will expand a lot. So we will see a lot of like small scale robotics for sure. And also I think that the AI assistants are very poorly integrated into the larger ecosystem. So for example, when I use Gemini to some extent when I drive in my car, and then I get a message, and then it's like says, okay, do you want to reply to this message? And then it's completely off the trail of the trail. I don't know how they can screw this up so much, but yeah, it's not very. Sometimes I say yes, and then yes, send yes. I want to. I just wanted to say yes. I want to reply to the message, but then no, it sends already. Or like I say something and I say, you want to play this music, and then it starts playing some music. so, I think yeah, I mean, it looks like very rudimentary yet. So I think it needs a lot of polishing and work. What I really excited about is those areas where AI does something that is impossible today. I mean, if you say, okay, I wait until my message, I can use my cell phone, don't drive my car, I will send the message then, so it's fine. But I mean, if you want to, let's say, solve like hard problems like energy production or solve cure diseases or make people happier, that I think then these things, that's what I think is the most interesting applications of AI will happen. And what is really, I think, is what I really enthusiastic about in the long run is that to use AI to analyze people to understand ourselves much better. And I think so. Currently, AI people try to create this AI assistant that tries to make people feel good, but they are not really measuring people. They don't help us to improve or don't help us to actually understand ourselves. So I think a useful AI would be that gives you good enough feedback that helps you to improve. And that's what we badly need.
Got it, Chris. So with your goal, like the formal approach, well, I don't know what the right term, but like let's say formal AI, that's going to
that
be like
formal
the
approach is
highest.
good.
Yeah, the formal, that's like the highest level of
Yeah,
truth.
standard. Yeah.
Whereas right now, a lot of our AI is informal, was being
Yeah.
trained off a lot of non-proof data, and that's a
It's
problem.
a lot of informal data. I mean, even the proofs can be informal. Most proof existent in the internet is informal. But it's written by humans for humans, so it's not really uh, trivially checkable by a computer. So you need AI to even understand it. So and the AI is not very good at, and it makes mistakes. So yeah. So formal means is basically is a similar thing as using code versus using natural language. And of course, it's you would say, okay, why would you go back to doing code when you're just getting away from code, so everything is in natural language? And that might be true. I don't really know. I mean, there are good arguments for that. But I think that there are safety arguments for the others because if you can create AI that creates like guarantees of correctness for your outputs that can be checked without AI, that you don't have to trust the AI to be correct. So it's also a good protection against bad AI, that AI that tries to subvert you. So that we don't want the AI to subliminally subvert humans because they just. So there is a danger that AI will try to have its own agenda and create dangers for us that we cannot really control. And the later we recognize that, the harder will it be to actually counteract it.
And by figuring out sort of formal AI, that solves that. That's like the root
No,
solution.
it doesn't solve it, but I mean, it adds an extra safeguard.
Mm.
So what I think is like formal keeps AI honest in some sense that it cannot be as subversive as otherwise could.
Yeah, because if it's formal, it has to be proven. It has to be a fact for it to say
Yeah.
it. So it can't.
Yeah, but first of all, I mean, the what you have to believe still is that the specification is correct.
Mm.
So that the formal specification, and there is no good guarantee. So it's like it's per definition. So the the specification's correctness cannot be formally verified because
Yeah, yeah,
because
yeah.
it comes from the informal. So the informal is not formal. So yeah. So and a lot of things cannot be formally specified. Only certain aspects maybe. So I think more things can be specified formally than most people think or recognize, but still less than would be necessary for full safety.
I see. Is this a specification? Because I always hear Elon Musk say that his goal is to create the most truth-seeking AI. Is that a specification?
I mean, not in my language. So for me, a specification is a formal description. So it's basically some code that it has to be in a formal language. And if you say truth-seeking AI is not a formal language, there is no definition of truth-seeking. There is no formal definition. There could be certain specifications of it that I could come up with, but I don't think they would align with Elon's intention completely.
Got it. And I guess what are the specification that you are pushing for, Chris?
For example, when it's like a code, so you say I want a code that prepares my taxes, for example.
Hmm.
Then you have to specify exactly so what is a good tax return or a good tax document, and that basically it has a lot of rules, and then all those rules could be turned into formal mathematics basically. And say if it's greater than this number, then this should happen. If it's blah blah, etc. So and that could be specified by a program. So the program would basically go, you run the program and then it checks your tax return and then says, okay, is it correct or incorrect? But I mean, there are other programs that they are much harder to specify. So for example, if you say I want to have a program that detects cats in an image, then how do I specify what is a cat? It will. So it's yeah. Good luck with that. So it's so and in that case you can still give some guarantees of saying here are 10,000 cats, images of cats, and please make sure that none of the windows in this would be recognized as a cat by a neural network that was trained on those cats, blah, 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 blah. So I could describe it mathematically what roughly means, what a cat is, but it would be a very statistical definition of catness. But it's still possible. So after you gave that definition, you can say, okay, now I want to have a program that detects cats much faster, and then but with the same guarantees, and then you can optimize. So you could use this AI. That has specifications and can verify programs alignment with the specification. You could use that AI to optimize programs so that they perform much faster or with much less memory or with higher certainty.
Got it. Because
So
like,
basically we would have these self-improving systems that you just specify the problem and it gets better and better at it.
so right now, if we want to create an AI that detects a cat, we give it a million photos of a million cats. We self sort of catalog each one manually with humans. We have different lightings, different angles, and we tell it, hey, based on all this data, recognize if, look for cats. That's still informal, correct? Because that's no guarantee.
Yeah, it's not a guarantee, but it's like, let's put it this way. I mean, it's a statistical guarantee that you have a certain probability of something not recognized as a cat if it's a cat, or there is a certain probability of something doesn't get recognized as a cat when it is a cat.
Mm.
And then you can say, okay, I mean, these are all cats, and then give me the probability that something is a cat based on those images. And you could formally specify that if I train the neural network arbitrary architecture, then so catness means that all those that majority of those neural networks would recognize those things as a cat, and that's the definition of catness.
Yes.
So basically, it's kind of a roundabout way of thinking about, but it's one way of defining catness, and it's a statistical definition. It's not
Yes.
really something that says, okay, this is formally the catness means that the ears are this way and the eyes are that way, and I describe that with 100% certainty, but it would be more like, yeah, a statistical definition.
I can formally agree
But
that.
chip design has a lot of this kind of similar things. So when you do chip design, that you don't verify that typically that your chip is satisfying, that your chip's output satisfies certain properties. You typically verify that it's equivalent to another simpler version of the chip, so that it always produces the same output as another chip, that the reference version. And this is the same idea here, that you can say, okay, I mean, I have a reference catness detector, and now I have to say, okay, I detecting cats, but I mean, it can be anywhere in the image, so give me all the locations where there is a cat. And then, of course, if you would just look at all the locations, that would be too much time, because there's like a lot of different rectangles you could check for catness, but that the task would be, is there a faster way of finding all the cats? But you are checking it to the reference implementation that is super slow, but it's easy to formalize.
Wow. Chris, I always hear the word chips, and I know computer chips, I know what it looks like, but what is a chip? I didn't know that you have to verify chips. What is a chip, I guess?
Oh, I mean, there are a lot of different kind of chips. So, for example, the processor in your computer is typically a chip, but there are a lot of much simpler chips. Like all the electric devices are full of chips. These are logic circuits that can do various functions, and then some of them are just doing like very simple computations. That, for example, they just control some thermostat very easily. But most chips today are very complicated. They contain billions of gates, logical functions, and then all these gets like executed simultaneously. So they perform extremely complex logic. So the chips that, for example, the most sophisticated chips are these GPUs that can perform millions of multiplications parallel for AI workloads. And then so they can contain like hundreds of billions of gates, and they are pretty big. So when you verify a chip, you are basically saying, yeah, it really multiplies the matrices, and then you're proving that. And it's tricky to verify, because there are a lot of things that can go wrong. One is the logically, you are not connecting the gates the right way. And I mean, imagine that you have to verify 100 billion connections. But also, what could go wrong is that the signals don't arrive in time, or that when you are lighting the chip, the wires don't have the right shape and they have too much resistance, or that. And all these have to be verified. Chip verification is kind of like, it's like you're working on insane amount of data, like terabytes of data, and you have to verify that each byte on those terabytes must be absolutely perfect in order for the chip to work. It's really crazy that all these things works today, and verification actually is more costly than designing the chips. So people spend more money on verifying them. And we don't verify computer code at all. So that's the crazier thing, that we should verify computer code as well, because it's just as important as the chips that we are running on.
Just so I can understand, like, what was like the first ever chip? What was the one gateway or the one task? Like if we go to the fundamentals, like what was the first ever chip? Just so I can understand how it now works.
So basically, chips were not the first to do the same thing. So basically, there were circuits before, and those circuits relied on like so-called vacuum tubes. So it's basically a switch that if you have some what is it, voltage on some of the lines, then it lets the electricity flow through that switch. Otherwise, it doesn't let the electricity. So it basically then it has infinite resistance, and it's a switch. And then the original implementation with vacuum tubes, and people used it until the 60s. But then they discovered transistors a bit earlier, but still vacuum tubes were used until the 60s, and in the early 60s they started to use transistors for switch. And you can use transistor to build any logical circuit, like for example, you can build a circuit that multiplies numbers, for example, certain size, or adds numbers, or performs that and then at the end of the 60s, they started to make these circuits integrated. So it's like they didn't build it from individual components. So basically they started to just draw them on this circuit board and then etch them out. And then that was originally done manually. And then they started to light them. And then so basically automated the process that humans didn't have to draw them. And so basically they get better and better at miniaturizing all these circuits, and that allowed people to. So the first chips were in the early 70s. They were the 404, Intel 404. That was the first generation of these Intel chips that were general purpose, that could execute programs. And then they got bigger and bigger. I mean, the circuit elements got smaller and smaller, but that allowed us to put more on them after a while. And so now we are at the point where these elements are so small that they are a few atom wide, and we can put like 1 trillion of them on a single die.
Wait, so this calculator I bought for $20, it has like I guess a chip behind it that looks pretty big. It does math. That chip is now like in the iPhone, this chip this big is compressed in a tiny atom? Is that how it works?
I mean, not the whole chip. I mean, so the structure element, so a single logic gate. And I think that guy in that, so this still has a chip, and it has logic gates, but those logic gates are much bigger, but they are still small for your eye. So it's like maybe like a wide as your hair or whatever, but that's huge compared to an atom.
Yeah.
And then it's like you get like million times or less big. So it's basically so small that every of these little tiny pieces, like every transistor, so basically it's built out of transistors, and each transistor is like a few atoms wide. So it's like insanely small. So that we are at the limit of what we can. So it's like the latest technology is 2 nanometers wide, but it's kind of like I think it's more like a beta number at this point. It's not clear what it exactly means, but so they are still in the order of nanometers, and that's kind of like the order of atoms. So maybe 10 atoms.
And all this research and machinery, is it done in Taiwan? Is it done in America?
I mean, there are factories so there are different ways of, so there are a lot of components that go into making the chips, and one is that one that creates the dies, and they are machines that are manufactured in Netherlands, but they are used in the big factories, and like Samsung and Taiwan, so the TSMC, and also Intel now. But I mean, Intel is a bit behind in the technology. IBM was in the game as well for a while, but they got out. And so it's like they are mostly in Japan, Korea, Taiwan, and the US, the chip factories. I don't think that anybody else has like this really sophisticated ones. China has pretty good ones, but they are still like much bigger transistors, so they can put less on the same size, and they will be also slower. So and require more power. But China is catching up. So yeah, we don't know how far they are, I think.
Got it. How do you find living in America? Like, would you ever want to move back to Hungary? What's your thoughts on the current dynamic of the world with all the different powers, superpowers going on?
Yeah, it's tricky. I mean, yeah, I intentionally, I could have been American citizen, but I decided to stay as a permanent resident for now. So and actually I have German citizenship. So I spend a lot of time in Europe, and I thinking of going back to Europe later when my mission is fulfilled, and I managed to make this company. I also started some other companies in Hungary and Europe. So yeah, I'm very so I like Europe a lot. It's beautiful and more variety than the US. Uh, I like a lot of things about the US, like the environment for entrepreneurship, and the technological progress and meeting really clever people. So it's like the concentration of great people is like really high in the Bay Area. So you cannot find anything similar anywhere else, in my opinion, like in the technological domains. But I mean, there are also drawbacks to living here. I don't like this car-centric culture and the homogeneity of the culture a bit. So I like Europe a lot. Like it's more pleasant and much more variety to go around and have like different cultures very close by. I like that a lot.
I love that, Chris. Have you tried or ever wanted to start a company with your brothers?
Brothers, I mean, not really, no. Yeah, I mean, Mario was interested to say, so yeah, he was involved a bit in this verified intelligence because superintelligence because he is, I mean, he also wants to learn AI and wants to work in this domain, but we stopped collaborating more or less. But yeah, he might resume. Yeah. I might involve him, but I don't think they are very theoretical people. They wouldn't. I mean, I'm also not the best entrepreneur kind of person, so I try not to be like. I don't want to be a CEO or really like an executive in the traditional sense. So I'm always relying on other people of doing the most of the business decisions and the administrative work and everything else. I like to more like being on the technical side.
Chris, in the future, do you think is it gonna be a one winner takes all situation? Like when you look at Grok, Gemini, OpenAI, do you think three can exist at the same time, or is it gonna be a winners take all?
Yeah, I mean, I think there will be multiple existing, and I hope that they will competing, and I hope there will be new ideas coming up and challenging them. Yeah, I'm not sure if it will happen or not. So maybe it will be. It would be very sad if we have a monopoly. I think currently it's really nice that we have like multiple big companies competing, and that's a very healthy thing. And I hope it continues. But yeah, there is a danger that AI might go so fast that the fastest one will improve the fastest and then just jumps ahead of everything else. And I mean, it's not clear to me that it will happen or it wouldn't. So it's really, yeah, I hope it doesn't happen. Yeah, it's not clear.
And Chris, I guess you'll be unaffected because you're in your own lane doing formal AI, which is completely different.
No,
Or
I
will you be
mean, we
affected?
want to, no, 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 we will be, I mean, we want to compete on being like the best AI in reasoning. So it's basically it will compete with other AIs in the reasoning arena. So the question is our formal approach better than the informal? And even if yes, then there are competitors like DeepMind is also working on formal methods to some extent. But I don't think they are as focused as we are.
What is DeepMind? Which company owns DeepMind?
Google.
Oh, when you was at Google, did DeepMind, was they already working on this problem, or did they start working it after you leave? Because this is sort of what you've wanted.
Yeah, they started just when I left.
Oh, and you're pushing for it, correct?
Yeah, we're pushing for it, but yeah, I mean, DeepMind was in London, and those people mostly worked in London. I was in Mountain View, so I didn't have many interaction with them. And DeepMind was back then not really, so it was basically a separate company for a while, and then they integrated it back to Google just a week after I left Google. So that's why they tried to get me back to Google as well, but I didn't want to go back. Yeah.
I see. Why not?
Yeah, because we started xAI and then it looked like a good opportunity.
Oh, that was the next thing. Okay. I see. Thank you so much, Christian. This is such a deep dive. I'm definitely out of my comfort zone. You're
Sure.
so technical, so smart. So I'm just trying to grasp and trying to understand. So I've been trying my best, but you've been able to really graciously sort of dumb things down and make it in a way where I can digest it. And I guess if I can digest it, so can the audience. So thank you, Christian.
Yeah, thank you very much for the invitation and yeah, have a good night or day or whatever is there. Okay.
Uh,
See you.
Christian, there's two
Yeah.
questions we usually wrap up
Yeah.
these podcasts with.
Uh,
One, any recent discovery habits, new things you've implemented to your day-to-day life? Or what's the
I mean, I
last thing?
always I always change my day-to-day life. So yeah, I mean, I'm doing much more walking and I try to exercise more thoroughly. But yeah, it's always changing. But yeah, walking is something I definitely do every morning, like an hour. It's not so much necessary for health, but I mean, it's also so keeping one more relaxed a bit and gives a good routine. Yeah, but I mean, not really. Yeah. So I mean, I'm trying to add more routine to my life. Yeah.
Love that. And then over the next 6 months, any personal goals that isn't work related?
Mhm. Not really. No, I think I spent the past year and a lot of like personal goals, and I have to get back to do more work on the professional front. Yeah.
And Chris, I guess where can people get more of you? People who are listening to this, how can they get more? How can they follow you? How can they get more of Chris?
Yeah, I mean, an X, I'm reasonably active. So I have CHR Szegedy is my handle. And of course, I'm on LinkedIn. And I mean, I look at it every week once, I think, but still I react to some. If the message is interesting, then I react to it. Yeah. And also we have like a math.inc webpage, and you can contact us there.
Perfect. Math. Can you give me the
Math.inc. Yeah. math.inc.
perfect? And then your X handle. How do you spell it?
CHR, like Christian, Szegedy, my last name. So in one single word.
Beautiful, Chris. Thank you so much. I know it's late over there. It's currently midday over here. Thank you so much. I love how passionate you are, how honest you are, but at the same time, I could feel the caring that you have for the future through the screen, and I'm so grateful for your time today. Thank you very much, Chris.
Yeah, thank you. It's my pleasure. Thanks a lot.
Guys, if you made it this far, hope you guys got some value from the episode. Please let me know your thoughts, and I'll see you guys next week. Peace.